Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 2, October-November 2018. Let's get started. The Muller family are on holiday in New Zealand. They changed some euros and received 1,962 New Zealand dollars. The exchange rate is €1 equals $1.635. Calculate the number of euros they change. If the exchange rate is €1 equals $1.635, then what will be the amount of euros received for $1,962? This is what we are calling x. When we cross multiply and make x the subject, this is what we have. This gives us 1,200 euros. The family spent 15% of their New Zealand dollars on a tour. Calculate the number of dollars they have left. The remaining amount would be equal to $1,962 minus the amount they spent on the tour, which is 15% of $1,962. When we type this into the calculator, we get $1,667.70. The family visits two waterfalls, the Humboldt Falls and the Bridal Veil Falls. The ratio of the heights Humboldt Falls is to Bridal Veil Falls equals 5:1. The Humboldt Falls are 220 meters higher than the Bridal Veil Falls. Calculate the height of the Humboldt Falls. We've been given the ratio of the heights of the falls as 5:1. We are told Humboldt Falls is 220 meters higher than the Bridal Veil Falls. This means if the Bridal Veil Falls is x meters high, then the Humboldt Falls is 220 plus x meters high. When we cross multiply, this is what we have. When we subtract x from both sides, we get 4x equals 220. And when we divide both sides by 4, we get x equals 55. The value of x is the height of the Bridal Veil Falls. So to get the height of the Humboldt Falls, we add 55 meters to 220 meters, which is equal to 275 meters. Water flows over the Brown Falls at a rate of 3,680 liters per second. After rain, this rate increases to 9,752 liters per second. Calculate the percentage increase in this rate. The percentage increase is equal to the increase in the flow rate, which is 9,752 minus 3,680 liters per second, divided by the initial flow rate, which is 3,680 liters per second, times 100%. This gives us 165%. After rain, water flows over the Sutherland Falls at a rate of 74,240 liters per second. This is an increase of 45% on the rate before the rain. Calculate the rate before the rain. Since there is a 45% increase on the flow rate before the rain, we add 45% to 100%, which is 145%. So we have 145% of the flow rate before the rain equals 74,240 liters per second. When we make the flow rate before the rain the subject, this is what we have, which is equal to 51,200 liters per second. Solve 30 plus 2x equals 3 times 3 minus 4x. When we expand the brackets, 3 times 3 is 9. 3 times negative 4x is negative 12x. When we group like terms, this is what we have. When we divide both sides by 14, we get x equals negative 1.5. Factorize 12ab cubed plus 18a cubed b squared. The common factor is 6ab squared. When we factor that out, we are left with 2b plus 3a squared. Simplify. 5a cubed c squared times 2a squared c raised to the power 7. 5 times 2 gives us 10. A raised to the power 3 times a squared becomes a raised to the power 3 plus 2. C squared times c raised to the power 7 becomes c raised to the power 2 plus 7. 5 times 2 is 10. 3 plus 2 is 5. 2 plus 7 is 9. So we have 10a raised to the power 5, c raised to the power 9. Simplify. 16a raised to the power 8 divided by c raised to the power 12, all raised to the power 3 over 4. By applying the laws of indices, the power 3 over 4 affects all the terms in the brackets. So we have 16 raised to the power 3 over 4 times a raised to the power 8, all raised to the power 3 over 4, divided by c raised to the power 12, all raised to the power 3 over 4. 16 raised to the power 3 over 4 is 8. The powers of a multiply. So 8 times 3 over 4 gives us 6. The powers of c multiply. 12 times 3 over 4 gives us 9. So we have 8a raised to the power 6 over c raised to the power 9. Y is inversely proportional to the square of x plus 2. When x is 3, y is 2. Find y when x is 8. In mathematical terms, we write y is inversely proportional to the square of x plus 2. This can be rewritten as y is equal to a constant, which we are going to call k, times 1 over x plus 2 squared. We need to find the value of k. We can get this by plugging in the values of x and y given in the question. This gives us 2 equals k over 3 plus 2 squared. When we make k the subject, we get 50. So now if x equals 8, then y equals 50 over 8 plus 2 squared, which is equal to 0.5. Write as a single fraction in its simplest form. 5 over x minus 2 minus x minus 5 over 2. We get the LCM by multiplying the two denominators. For 5 over x minus 2, since we multiplied the denominator x minus 2 by 2 to get the LCM, then we also need to multiply the numerator 5 by 2. For x minus 5 over 2, since we multiplied the denominator 2 by x minus 2 to get the LCM, we also need to multiply the numerator x minus 5 by x minus 2. 5 times 2 is 10. When we expand x minus 5 times x minus 2, we get x squared minus 7x plus 10. When we expand the brackets, negative 1 times x squared is negative x squared. Negative 1 times negative 7x is 7x. Negative 1 times 10 is negative 10. 10 minus 10 is 0, so we have 7x minus x squared over 2 times x minus 2. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangles A and B, they have the same size but their orientation is different, which means the transformation is either a reflection or a rotation. When we rotate triangle A 90 degrees in the clockwise direction, we get triangle B. For a 90-degree rotation, the way to determine the center of rotation is this. We connect at least 2 corresponding points on both triangles. Then we draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation, which in this case is the origin. And so the full description for the transformation would be rotation 90 degrees clockwise about the origin. On the grid, draw the image of triangle A after a reflection in the x-axis. In this case, the line of reflection is the x-axis. So now we need to reflect the vertices of triangle A in the x-axis. So for point A on the triangle, since we move 1 unit downwards to touch the line of reflection, we also need to move 1 unit downwards from the line of reflection to pin the new position of point A. We need to repeat the same process for points B and C on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. On the grid, draw the image of triangle A after a translation by the vector 7, -5. For this translation, the translation vector dictates that we move each of the vertices of triangle A 7 units to the right and 5 units downwards. On the diagram, the movement for point C has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle A. On the grid, draw the image of triangle A after the transformation represented by the matrix 0.50, 0, 0.5. The given matrix represents an enlargement by a scale factor 0.5 about the origin. So now let's apply this transformation to triangle A. First, we mark the center of enlargement, which is the origin. Now let's pin the new position of point C. To get to the initial position of point C from the center of enlargement, we move 2 units to the left and 4 units upwards. So to pin the new position of point C, we need to move in the same direction since the scale factor is positive. Since the scale factor is half, we move half of the distance covered initially. So now, to pin the new position of point C, we move 1 unit to the left and 2 units upwards. After repeating the same process for the rest of the vertices as well, we are able to map out the new image of triangle A. The diagram shows a right-angled triangle ABC. The area of this triangle is 30 centimeters squared. Show that 2x squared plus 3x minus 20 equals 0. Here is the formula for the area of a triangle. We've been given the area of the triangle as 30 centimeters squared. The base B of the triangle is 2x plus 5 centimeters and the height h is 4 times x minus 1 centimeters. On the right side of the equation, we see that half times 4 is 2. When we divide both sides by 2, this is what we have. When we expand 2x plus 5 times x minus 1, we get 2x squared plus 3x minus 5. When we move all the terms to one side of the equation and group like terms, we get 2x squared plus 3x minus 20 equals 0. Use factorization to solve the equation 2x squared plus 3x minus 20 equals 0. First, we can rewrite 3x as 8x minus 5x. For the first two terms, the common factor is 2x. When we factor out 2x, we are left with x plus 4. For the final two terms, the common factor is -5. When we factor out -5, we are left with x plus 4. This can be rewritten as 2x minus 5 times x plus 4 equals 0. When we equate 2x minus 5 to 0, we get x equals 2.5. And when we equate x plus 4 to 0, we get x equals -4. Calculate BC. To get the length of BC, we apply the Pythagoras theorem to triangle ABC. This gives us b squared equals ab squared plus ac squared. The sides of the triangle cannot be negative. So to get the length of AB and AC, we plug in the positive value of x we got from the previous solution. This gives us AB to be 6 centimeters and AC to be 10 centimeters. When we make BC the subject and plug in the values of AB and AC, this is what we have, which is equal to 11.7 centimeters rounded to 3 significant figures. The table shows some values of y equals x cubed minus 3x minus 1. Complete the table of values. When we plug in x equals -2 into the equation, we get y equals -3. For x equals 3, we get y equals 17. Draw the graph of y equals x cubed minus 3x minus 1 for x is greater than and equal to -3 and less than and equal to 3. On the grid, we plot all the points in the table and connect the points with a smooth line. A straight line through 0, -17 is a tangent to the graph of y equals x cubed minus 3x minus 1. On the grid, draw this tangent. On the grid, we've drawn the tangent, which is simply a straight line that passes through 0, -17 and touches the curve at one point. Find the coordinates of the point where the tangent meets your graph. On the grid, we see that the tangent meets the graph at 2.12. Find the equation of the tangent. Give your answer in the form y equals mx plus c. All we need to do is find the values of m and c and plug in these values into y equals mx plus c. To get the gradient m of the tangent, we need to pick 2 points on the tangent. By applying the gradient formula, we have m equals 2 minus -17 divided by 2.1 minus 0, which is equal to 9. The value of c is simply the y-coordinate of the point on the y-axis through which the tangent passes, and that is -17. So we have y equals 9x minus 17. By drawing a suitable straight line on the grid, solve the equation x cubed minus 6x minus 3 equals 0. First, we need to rewrite the equation to leave the function of the curve on one side of the equation. To do this, we rewrite minus 6x as minus 3x minus 3x, and we also rewrite -3 as minus 1 minus 2. So now we leave the function of the curve, which is x cubed minus 3x minus 1, on one side of the equation and move the other terms to the other side of the equation. This means we need to draw the line y equals 3x plus 2 on the grid and note the x coordinate of its intersection point with the curve. On the grid, we've drawn the line y equals 3x plus 2 and the x coordinates of the intersection points are -2.15, -0.5 and 2.7. The diagram shows the speed time graph for part of a journey for two people, a runner and a walker. Calculate the acceleration of the runner for the first 3 seconds. To get the acceleration, we simply need to find the slope of the runner's graph for the first 3 seconds. This gives us 3.0 minus 1.2 meters per second divided by 3 minus 0 seconds, which is equal to 0.6 meters per second squared. Calculate the total distance traveled by the runner in the 19 seconds. The area under a speed time graph gives us the distance traveled. The area under the runner's graph can be split into two, which we have labeled as D1 and D2. D1, which is in the shape of a trapezium, has an area of half of a plus b times h, where a plus b is the sum of the parallel sides of the trapezium, and that is 12 plus 19. And h is the height of the trapezium, which we get by subtracting 1.2 from 3. D2, which is in the shape of a rectangle, has an area of L times W, where L is 19 and W is 1.2. When we type this into the calculator, we get 50.7 meters. The runner and the walker are traveling in the same direction along the same path. When t equals 0, the runner is 10 meters behind the walker. Find how far the runner is ahead of the walker when t equals 19. From the illustration, we've labeled this distance as x. We see that x is equal to the distance traveled by the runner, which is 50.7 meters, minus the distance traveled by the walker, which we've gotten as 22.8 meters minus 10 meters. This gives us 17.9 meters. In the diagram, A, B, C, and D lie on the circle center O. EA is a tangent to the circle at A. Angle EAB is 61 degrees and angle BAC is 55 degrees. Find angle BAO. The angle formed between a radius and the tangent is 90 degrees. So angle BAO plus 61 degrees equals 90 degrees. When we subtract 61 from both sides, we get angle BAO as 29 degrees. Find angle AOC. To get this angle, we subtract 29 degrees from 55 degrees, which gives us 26 degrees. OA and OC are radii of the circle, which makes triangle AOC an isosceles triangle. Base angles in an isosceles triangle are equal. The sum of the angles in triangle AOC must add up to 180 degrees. So we have angle AOC plus 26 equals 180. When we make angle AOC the subject, we get 128 degrees. Find angle ABC. The angle chord AC subtends at the center of the circle must be twice the angle it subtends at the circumference. This means angle ABC is half of 128 degrees, which is equal to 64 degrees. Find angle CDA. Opposite angles in a cyclic quadrilateral must add up to 180 degrees. So angle CDA plus 64 equals 180. When we subtract 64 from both sides, we get angle CDA to be 116 degrees. The diagram shows the positions of three cities: Geneva, Budapest, and Hamburg. A plane flies from Geneva to Hamburg. The flight takes 2 hours 20 minutes. Calculate the average speed in kilometers per hour. Here is the formula to find the average speed. The distance d from Geneva to Hamburg is 864 kilometers. The time duration for the flight is 2 hours 20 minutes. We divide 20 by 60 to convert it to hours. When we type this into the calculator, we get 370 kilometers per hour, rounded to three significant figures. Use the cosine rule to calculate the distance from Geneva to Budapest. When we apply the cosine rule to triangle BGH, this is what we have. GH is 864 kilometers, BH is 928 kilometers, and angle GHB is 67 degrees. When we make GB the subject and plug in these values, this is what we have. When we type this into the calculator, we get 991 kilometers, rounded to three significant figures. The bearing of Budapest from Hamburg is 133 degrees. Find the bearing of Hamburg from Budapest. On the diagram, we've indicated the bearing of Hamburg from Budapest. We've also indicated the bearing of Budapest from Hamburg, which is 133 degrees. These two are interior angles, which means they add up to 180 degrees. So to get this angle, we subtract 133 degrees from 180 degrees, which gives us 47 degrees. So now, the bearing of Hamburg from Budapest would be 360 degrees minus 47 degrees, which is equal to 313 degrees. Calculate the bearing of Budapest from Geneva. On the diagram, we've indicated the bearing of Budapest from Geneva, which is equal to 20 degrees plus angle BGH, which we've labeled as alpha. How did we get the 20 degrees? Angles around the point add up to 360 degrees. So to get this angle, we subtract the sum of 133 degrees and 67 degrees from 360 degrees, which is equal to 160 degrees. These two are interior angles, which means they add up to 180 degrees. So to get this angle, we subtract 160 degrees from 180 degrees, which gives us 20 degrees. Now we need to find the value of alpha. We can get alpha by applying the sine rule to triangle BGH. This gives us sine alpha divided by 928 kilometers equals sine 67 degrees divided by 991 kilometers. When we make alpha the subject, this is what we have. When we type this into the calculator, we get 59.5 degrees rounded to one decimal place. So now the bearing would be 20 degrees plus 59.5 degrees, which is equal to 79.5 degrees. The table shows the amount of time T minutes 120 people each spend in a supermarket one Saturday. Use the midpoints of the intervals to calculate the estimate of the mean. The mean is equal to sigma f of x, which represents the total time spent in the supermarket on Saturday, divided by sigma f, which is the total number of people who shopped in the supermarket. Before getting sigma f of x, we need to get the midpoints for each of the time intervals. So for the first interval, the midpoint is 10 plus 30 divided by 2, which is 20. Then we have 30 plus 40 divided by 2, which is 35. 40 plus 45 divided by 2, which is 42.5. 45 plus 50 divided by 2, which is 47.5. 50 plus 60 divided by 2, which is 55. 60 plus 70 divided by 2, which is 65. So for sigma f of x, we have 20 times 16 plus 35 times 18 plus 42.5 times 22 plus 47.5 times 40 plus 55 times 21 plus 65 times 3 minutes divided by the number of people, which is 120. When we type this into the calculator, we get 42.8 minutes rounded to 3 significant figures. Complete this histogram to show the information in the table. To be able to draw the histogram to show the information, we need to calculate the frequency density for each of the given time intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is the frequency, which is 16, divided by the interval width 30 minus 10, which is equal to 0.8. This interval has already been drawn on the histogram for us. Then we have 18 divided by 40 minus 30, which is equal to 1.8. Then we have 22 divided by 45 minus 40, which is equal to 4.4. 40 divided by 50 minus 45, which is equal to 8. 21 divided by 60 minus 50, which is equal to 2.1. So now, after marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. This histogram shows the amount of time T minutes 120 people each spend in the supermarket one Wednesday. Make a comment comparing the distributions of the times for the 2 days. When we compare the histograms, we see that the height of the bars on the histogram for Wednesday are generally shorter than the height of the bars on Saturday. So we can say on average, people spend less time in the supermarket on Wednesdays, Or we can also say people spend more time in the supermarket on Saturdays. The lake behind the dam has an area of 55 hectares. When the gates in the dam are open, water flows out at a rate of 75,000 liters per second. Show that 90 million liters of water flows out in 20 minutes. The volume that flows out is equal to the volume flow rate times the time. The volume flow rate has been given as 75,000 liters per second and the time is 20 minutes. We convert 20 minutes to seconds by multiplying 20 by 60. When we type this into the calculator, we get 90 million liters. Beneath the surface, the lake has vertical sides. Calculate the drop in water level of the lake when the gates are open for 20 minutes. Give your answer in centimeters. The drop in the volume of the water in the lake is equal to its cross-sectional area times the drop in height of the water. We are interested in finding the drop in height of the water. So when we make that the subject of the equation, this is what we have. The drop in the volume of the water is 90 times 10 raised to the power 6 liters, which we convert to meters cubed by dividing by 1000. The cross-sectional area of the lake is 55 hectares, which we convert to meters squared by multiplying 55 by 10 raised to the power 4. When we type this into the calculator, we get 9 over 55 meters. We need our final answer to be in centimeters, so we multiply 9 over 55 by 100 to convert it to centimeters. When we type this into the calculator, we get 16.4 centimeters rounded to 3 significant figures. The cross-section of a gate is a sector of a circle with radius 8.5 meters and angle 76 degrees. Calculate the perimeter of the sector. The perimeter of the sector is equal to the distance around the shape of the sector. L1 and L2 are the radii of the sector, which is 8.5 meters. To get L3, we apply the arc length formula theta over 360 degrees times 2 pi r, where theta is 76 degrees and the radius r is 8.5 meters. When we type this into the calculator, we get 28.3 meters rounded to 3 significant figures. A solid metal cone has radius 10 centimeters and height 36 centimeters. Calculate the volume of this cone. We've been given the formula for the volume of a cone as 1 over 3 pi r squared h, where r in this case is 10 centimeters and h is 36 centimeters. When we type this into the calculator, we get 3,770 centimeters cubed, rounded to 3 significant figures. The cone is cut parallel to its base to give a smaller cone. The volume of the smaller cone is half the volume of the original cone. The smaller cone is melted down to make 2 different spheres. The ratio of the radii of these 2 spheres is 1:2. Calculate the radius of the smaller sphere. We've been told that the smaller cone is melted to make 2 different spheres. This means the volume of the small cone is equal to the volume of the 2 smaller spheres, which we are calling Vs1 and Vs2. We are told the volume of the smaller cone is half the volume of the larger cone, which is 3,770 centimeters cubed. And so the volume of the smaller cone would be 3,770 divided by 2 centimeters cubed. We are also told that the radii of the 2 spheres are in the ratio 1:2. This means if the volume of sphere 1 is 4 over 3 pi r cubed, then the volume of sphere 2 would be 4 over 3 pi times 2r cubed. 3,770 divided by 2 is 1,885, and 4 over 3 pi times 2r cubed simplifies to 32 over 3 pi r cubed. 4 over 3 pi r cubed plus 32 over 3 pi r cubed gives us 12 pi r cubed. When we divide both sides by 12 pi, this is what we have. And when we take cube root of both sides, this is what we get. When we type this into the calculator, we get 3.68 centimeters rounded to 3 significant figures. Find 3a minus 2b. We've been given vector a as negative 3, 2 and vector b as 5, 4. So to get the top element of the resulting vector, we have 3 times negative 3 minus 2 times 5, which is equal to negative 19. And for the bottom element, we have 3 times 2 minus 2 times 4, which is equal to negative 2. Find the magnitude of vector A. In this case, we need to apply the magnitude of a vector formula. This gives us square root of negative 3 squared plus 2 squared, which is equal to 3.61 rounded to 3 significant figures. MA plus NB equals C. Write down two simultaneous equations and solve them to find the value of M and the value of N. Show all your working. We've been given A as negative 3, 2, B as 5, 4, and C as 14, 9. From this, we can set up two equations to find the values of M and N. For the top element, we have negative 3m plus 5n equals 14, which we've labeled as equation 1. And for the bottom element, we have 2m plus 4n equals 9, which we've labeled as equation 2. Let's use the elimination method to solve these equations. First, let's multiply through equation 2 by 3 over 2. This gives us 3m plus 6n equals 13.5, which we've labeled as equation 3. Now that we have 3m in equation 3 and negative 3m in equation 1, we can eliminate m by adding equation 1 to equation 3. This gives us 11n equals 27.5. When we divide both sides by 11, we get n equals 2.5. To get the value of m, we plug in the value of n into any of the equations. If we pick equation 2, we have 2m plus 4 times 2.5 equals 9. 4 times 2.5 is 10. When we make m the subject, we get m equals negative 0.5. OAB is a triangle and C is the midpoint of OB. D is on AB such that AD is to DB equals 3 is to 5. OAE is a straight line such that OA is to AE equals 2 is to 3. OA is A and OC is C. Find in terms of A and C in its simplest form, AB. AB can be expressed as AO plus OB. AO is negative A. C is the midpoint of OB, so if OC is C, then CB is also C. This means OB would be 2C, so we have negative A plus 2C. Find AD. We've been given that AD is to DB equals 3 is to 5. This means AD is 3/8 of AD. We found AB in the previous question as negative A plus 2C. So when we expand the brackets, we get negative 3 over 8A plus 3 over 4C. Find CE. CE can be expressed as CO plus OA plus AE. CO is negative C. OA is A. We need to find AE. We've been given OA is to AE as 2 is to 3. If OA is A, then what is AE? This is what we are calling X. When we cross multiply and make X the subject, we get X, which is AE as 3 over 2A. A plus 3 over 2A is 5 over 2A, so we have 5 over 2A minus C. Find CD. CD can be expressed as CB plus BD. CB is C and BD is 5 over 8 of BA. It's very important to note that since we are moving from B to D, we can only say BD is 5 over 8 of B to A, which is BA, and not AB. BA is negative AB, and that is A minus 2C. When we expand the brackets and simplify, we get 5 over 8A minus 1 over 4C. CE equals K times CD. Find the value of K. When we make K the subject, we get CE divided by CD. We can't divide the two vectors, but instead, we can divide the magnitude of the two vectors to get the value of K. That will be a long process for 1 mark, so the shortcut is to simply divide the coefficients of A or C in both vectors. So if we pick the coefficients of A, 5 over 2 divided by 5 over 8 gives us 4. A box contains 20 packets of potato chips. 6 packets contain barbecue flavored chips. 10 packets contain salt flavored chips. 4 packets contain chicken flavored chips. Maria takes 2 packets at random without replacement. Show that the probability that she takes 2 packets of salt flavored chips is 9 over 38. In the first pick, the probability that Maria takes a packet of salt-flavored chips is equal to the number of packets of salt-flavored chips, which is 10, divided by the total number of packets, which is 20. Maria takes a first and a second packet. The n becomes times. After she takes out the first packet without replacement, the number of packets reduced by 1. And so the probability that the second packet she picks is also salt flavored is 9 over 19. When we type this into the calculator, we get 9 over 38. Find the probability that she takes 2 packets of different flavored chips. There are 3 possible scenarios in this case. The probability that she picks a packet of barbecue flavored chips and a packet of salt flavored chips, or the probability that she picks a packet of barbecue flavored chips and a packet of chicken flavored chips, or the probability that she picks a packet of salt flavored chips and a packet of chicken flavored chips. The probability that she picks a packet of barbecue flavored chips is 6 over 20. Without replacement, the probability that she picks a packet of salt flavored chips is 10 over 19. The order in which she picks the chips may be reversed, making the total number of possible orders to be 2. So we multiply this by 2. The probability that she picks a packet of barbecue flavored chips is 6 over 20. Without replacement, the probability that she picks a packet of chicken flavored chips is 4 over 19. The order in which she picks the chips may be reversed, so we multiply this by 2. The probability that she picks a salt flavored chips is 10 over 20. Without replacement, the probability that she picks a packet of chicken-flavored chips is 4 over 19. The order in which she picks the chips may be reversed, so we multiply this by 2. When we type this into the calculator, we get 62 over 95. Maria takes 3 packets at random without replacement from the 20 packets. Find the probability that she takes at least 2 packets of chicken-flavored chips. There are 3 possible scenarios in this case. The probability that she picks 2 packets of chicken-flavored chips and a packet of barbecue-flavored chips, or the probability that she picks 2 packets of chicken-flavored chips and a packet of salt-flavored chips, or the probability that she picks 3 packets of chicken-flavored chips. The probability that she picks a packet of chicken-flavored chips is 4 over 20. Without replacement, the probability that she picks another packet of chicken-flavored chips is 3 over 19. Without replacement, the probability that she now picks a packet of barbecue-flavored chips is 6 over 18. There are 3 possible orders in which she may pick up the chips, so we multiply this by 3. The probability that the first 2 packets are chicken flavored is 4 over 20 times 3 over 19. Without replacement, the probability that she now picks a packet of salt flavored chips is 10 over 18. There are 3 possible orders in which she may pick the chips, so we multiply this by 3. The probability that the first 2 packets are chicken flavored chips is 4 over 20 times 3 over 19. Without replacement, the probability that she picks a third packet of chicken flavored chips is 2 over 18. When we type this into the calculator, we get 5 over 57. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.